We're now going to give some definitions for some terms that are used with rational expressions. And so we're going to start with rational expressions. And a rational expression is any time we have a polynomial divided by a polynomial. So anytime we have a variable in the top and a variable in the bottom, we are dealing with a rational expression. Now, something that's really key here is that our domain of the rational expressions is anything that doesn't make a denominator 0. So in this case, it's everything but -1. So I plug a -1 in, it makes this 0 because -1 plus 1 is 0. Now, as we're looking at this, the numerator, just like it is with fractions, the numerator is the top polynomial. It's whatever's on top. And the denominator is the bottom polynomial. So in this case, our numerator is x squared minus 3x minus 4, and in this case, our denominator would be x plus 1. And for any given rational that we're dealing with, we can figure this out. So now we just spent some time talking about factoring in the last section. Well, in this section, factoring is the same thing. The factors are the things that are multiplied to give some result. So for instance, our x squared minus 3x minus 4 is our result, but that factors as x minus 4, x plus 1. And so our factors are the pieces, and in rationals it's really important that we factor everything at the end of a problem. We really like to leave this stuff in factored form because it's easier to see, easier to play with, easier to do. Okay, so now let's talk about what it means to divide out. And a lot of times a student or a teacher even might say cancel, but that's not really what's going on. So if you remember, this is our factor, and if we go back to our example, we start with x squared minus 3x minus 4 over x plus 1. Well, if I factor this, I now get x minus 4, x plus 1 over x plus 1. And notice that I have an x plus 1 factor on top and an x plus 1 factor on bottom. So these divide out because a over a is 1, and so they go away. And this leaves me with the result of x minus 4. And so the key here in dividing out is that everything about the factor has to be the same. For instance, I can divide out the x plus 1s, but if I have x plus 4 over x plus 2, this is done. I can't divide anything out because the x plus 4 is a factor and the x plus 2 is a factor, and these factors are not exactly the same, so they can't divide out.